Hello there, my name is McHorse, and welcome to a Snowstorm particle editor tutorial. In this video, I'll show you what kind of options Snowstorm offers for particle creation. By the way, this video contains a lot of math. I'll try my best to explain these concepts, but if you'll have troubles understanding them, feel free skipping them. So, Snowstorm is a particle editor made by Jannis. It's made for creating particle effects for Bedrock edition of Minecraft. Before Snowstorm, you'd have to manually edit JSON files, wasting lots of time writing fancy configuration. However, with Snowstorm, you can make those much easier with an organized and nice looking GUI editor. You can also use these particle effects in Java edition of Minecraft using Blockbuster mod, since version 2.0, thanks to Spark². Before we begin, let me quickly show you how to set up a Bedrock resource pack so you could test particles on Windows 10 edition. Download the sample resource pack provided in the description, then go to Users App Data, Local, Packages, Microsoft.Minecraft followed by some gibberish, Local State, Games, com.wang, Development Resource Packs. Unzip the only folder from Sample Resource Pack Archives to the Development Resource Packs folder, and now you'd be able to use this resource pack in Bedrock. Let's try placing one of the example particles from Snowstorm into Particles folder of the sample pack. If you'd place a command block and use the particle command with the ID specified in Snowstorm's identifier field, you'll see a rainbow. With Blockbuster, on the other hand, you just open the dashboard GUI, 0 key by default, click on the folder icon to open Particles folder, and drop a JSON file there. Then go to Creative Morph menu, B key by default, select Snowstorm Morph, press Q, and select the file name of that particle, and you'll see a rainbow. Blockbuster has its own in-game particle effect editor, very similar to Snowstorm. However, it's not 100% finished. Curve section, gradient color mode panel and proper UV editor are not implemented at the moment of making this video. Alright, let's start reviewing the options from top to bottom. Under effect category we have meter configuration sections of the particle effect. These sections allows to change meter values, and there are also tools to help configure other options indirectly. Identifier field allows to set the ID of the particle effect, which could be emitted with particle command. In Blockbuster mod, it acts as a display name though. Space category allows to configure particle effects local space. I'm not exactly sure how it works on Bedrock. However, according to documentation, it should look something like this. Here are some examples. Local position and rotation are disabled. Only local rotation is enabled. Although, it works the same way as both position and rotation are disabled. If you have content log GUI enabled, you'll see a warning that this mod local rotation without local position isn't supported. Only local position is enabled. Local position and rotation are enabled. And for now, we'll skip variables and curve sections, and we'll move on to emitter options. Sections in emitter category allow to configure how particle emitter behaves when and where it spawns particles. Particle emitter is basically this, not literally these three lines. However, it's an invisible object, which is responsible for handling creation of particles and their expiration, basically removing them. Rate section allows to configure how often particles emit during emitter's lifetime. There are two modes, steady and instant. Steady rate mode allows to set up how many particles will be emitted per second with the rate field, and maximum field allows to limit amount of particles that can be present at the same time. While instant mode allows to emit specific amount of particles at the start of emitter's playback cycle. Emitter lifetime section allows to configure playback cycles. There are three modes, looping, once and expression. Looping mode allows to loop emitter's playback cycles. Active time field determines for how many seconds it's active until next playback cycle, while sleep time allows to set up a pause between 2 cycles, in seconds. By default, there is no pause. Once mode makes the emitter play only once. Active time specifies for how long this single cycle will last for, in seconds. And expression mode allows to specify 2 math expressions that allow to arbitrarily play or pause the emitter. If activation expression yields non-zero value, then emitter will be activated. If the expiration field yields non-zero value, then emitter will be stopped. Setting 1 to both fields will make emitter start and stop every tick. Shape section allows to configure the initial position of the particle and its default direction. There are multiple shapes available: point, sphere, disk, box and entity bounding box. Point shape is the most basic shape. All it has is XYZ offset fields. With these, you can place the initial position of the particle. Think of it as a translation point. Beside having offset fields, sphere shape also has radius and surface only fields. Radius field allows you to set up a maximum distance from which particle will be emitted relative to the offset point. Radius is measured in blocks. Basically, if I'll set radius to 1, then particles will be spawned 1 block away, in random direction, from offset but limited to the radius. While surface checkbox makes particles spawn exactly at given radius, rather than from random distance away from the offset point, thus forming a sphere. Disk shape is really similar to sphere shape, however, it spawns particles on a 2D circle rather than on a sphere, if that makes sense. The rest of the fields are the same, for exception of plane normal. Plane normal allows you to rotate this disk, however instead of specifying rotation angles on individual axes, here you can specify a direction vector to which the circle will be perpendicular. Here is a little demonstration of how it works. Here we have a very thin donut in Blender. The green arrow is the plane normal. If I'll move the cursor here, it would show 0, 1, 0. Don't mind Blender's coordinate system, its Y and Z axes are swapped. So if we'll rotate the whole thing, let's say by 45 degrees on X axis, and move the cursor at this point again, we'd get another plane normal. That's how plane normal works. Box shape is almost identical in behavior to sphere shape. However, instead of having radius, it has 3 fields to specify the size of the box and blocks to which particles placement is limited to. Keep in mind that every of those size fields specifies only half of the box. So if you want the emitter to be 1 block cubed, you'd need to specify 0.5 in every of those fields. Surface only does the same thing. It places particles exactly on the edges of the box. And the final shape is entity bounding box. It's exactly same as the box shape. However, it will use entity's bounding box size. Next we have particle options. Appearance section allows you change the size of particles, facing mode and material. Since snowstorm particles are essentially quads, you can specify their width and height in blocks. Facing mode allows to change the way these quad particles are oriented towards the camera. The best way to show it is with the rain example particle effect. Rotate XYZ always orients particles towards the camera, no matter what the angle is. That's the mode which Java Edition uses for its particles. Rotate Y orients the particles only on Y-axis toward the camera. If we'll tilt the viewport down, we'd see that only the particles on the top half of the viewport are visible. That's because particles on the bottom half are facing the same direction and they're being culled due facing away from the camera. Look at XYZ orients the particles toward the camera as well. However, instead of using camera's orientation, it orients towards the camera using the angle between particles and camera's position. This creates this nice spherical effect when you're in middle. That's what Bedrock Edition uses for its particles. Look at Y works exactly the same as XYZ counterpart. However, it rotates the particle only on Y-axis. And direction X, Y and Z facing modes are basically orient particles based on particles' motion. Material option determines. Honestly, I have no idea. Documentation doesn't say anything about it. So yeah. JK. Jannis explained to me what they do. Opaque material makes textures semi-transparent or transparent pixels appear fully black. Alpha material will discard any semi-transparent pixels. And blend material will make, it doesn't work, but according to Jannis, it's supposed to make transparent pixels blend with the background. However, sometimes it can get messy. Let's skip direction section for a second, and we'll take a look at motion section. Here you can adjust particles. Motion. There are 3 motion modes: static, dynamic and parametric. Static is obvious. It does nothing. The particles will float on the place where they were spawned. Dynamic mode allows to configure motion using non-linear model. Speed determines initial speed, in blocks, of a particle in initial direction. The initial direction, surprise, can be configured in direction section. There are 3 modes: outwards, inwards and direction. Outwards and inwards direction modes are setting up the initial direction, either inwards or outwards the center of the shape, that is offset point. Obviously, it wouldn't work well with the point shape, or with shapes whose volume were configured to be 0. And direction mode allows to set up a custom direction, which is similar configuration wise to the plain normal. Going back to motion section, acceleration fields allow to modify the motion of particles after they've been spawned. These values will be added every tick to velocity of the particle, and they're measured in block per second. Air drag option allows you to set up some factor that will be slowing down particles. Think of it as air resistance. The higher the value, the more it decelerates. If you'll provide a negative value, particles will accelerate. And finally, parametric motion mode. You can use this mode to move particles based fully on math expressions. In offset fields, XYZ obviously, you write expressions that will make particles move according to some math expressions. More about math expressions later. And the direction field seems to be used only for direction XYZ camera facing modes. These fields don't affect motion in any way. Next we have rotation section, which allows to configure particles rotation across Z-axis. All of these fields are dealing with degrees by the way. There are 360 degrees in a full circle rotation. Start rotation determines the original rotation of a particle. Speed determines the static speed of rotation in degrees per second. Acceleration determines the additional value that will be added to the speed every tick, measured in degrees per second. And air drag slows down the speed of the rotation. There is also parametric rotation mode, which allows you to input a custom math expression which will be calculated every frame, instead of using non-linear dynamic system. Basically these options are exactly work the same way as the ones in motion section, but only applied to particles rotation. Lifetime section in particles category allows to configure for how long particle will stick around until disappearing. There are 2 modes, time and kill expression. Time mode allows to set for how many seconds will particle live. Meanwhile kill expression allows you to specify a math expression which upon yielding a non-zero value will kill the particle. Beside max time and kill expression fields, which are exclusive to their corresponding mode, there are also other non-exclusive lifetime options. Kill plane fields allow to specify a plane using 4-factor plane expression. Once a particle will cross this plane, they will expire. This is another math concept. Sadly there is no visualization within Snowstorm at the moment of making of this video, however it looks something like this in Blockbuster. I understand how it works, but I can't really explain how it works. Kill in blocks and only in blocks options allow you to specify block IDs. Block IDs in kill in blocks will expire the particle once the particle moves inside of one of the specified blocks. Meanwhile block IDs in only in blocks will expire once the particle is not located in any of the specified blocks. Think of these two as blacklist and whitelist for block IDs. Texture section allows you to change the texture of the particle effect, coordinate and size of the portion of the texture you want to use, and even animate coordinate shift. There are two UV coordinate modes, static and animated. Static mode allows you to set portion of the image which will be used for particle quads. If you'd open the image in an image editor and select a portion of the region, you'll be able to see somewhere the coordinate and size of the region you selected. This is one of the ways to find out these values. While animated mode allows to set up simple UV coordinate animation. Let's say we have this explosion-like animation at 0x80y in the default texture, consisting out of 16 frames. What we need to do here is to set UV start to 0 and 80, UV size to 8 and 8, UV step to 8 and 0, max frame to 16, and enable stretch to lifetime. Then we'll get that animation working. Alternatively, you can disable stretch to lifetime and enable loop, and set FPS to 16. As you might figure it out, UV step is the XY shift that will be added to the UV start every step. FPS is how many frame steps there will be in a second. Max frame is how many steps in total can be done in this single animation. Stretch to lifetime allows you to stretch the FPS value so it would perfectly match particle's lifetime. And finally, loop option allows you to loop the animation in case FPS is being too fast for particle's lifetime. Color and light section allows to configure particles texture tinting, that is, colorize it. There are 3 color modes here: static, expression and gradient. Before we get into these different modes, lighting checkbox determines whether Minecraft's light map will be applied onto the particle. In simpler terms, when disabled, particles will glow in the dark. Static mode allows you to tint the particle using a color picker. You'd achieve a greater effect if you'd use shades of gray in the texture, as colored particles might not work as you intend them to. Expression mode allows to set up color tint using math expression for individual color channels. That is, you can set up math expression of RGB channels. Math expressions here must yield values between 0 and 1. Gradient mode allows to set up a gradient upon which particles will be tinted. Here you can add colors and drag where they are located on the gradient. You also must specify a math expression in interpolant field, which tells the gradient how to animate through the gradient. Particle age over particle lifetime should be sufficient for most uses. Range field allows to space out the gradient stop values, so if I'll input 3 into range and multiply expression by 3, I'll get the same result. If we'll look up the code, we'll see that all color stops were multiplied by 3. And finally, collision section allows to enable particle collision with blocks in the world, which obviously can't be previewed in Snowstorm. Enabled checkbox enables collision for particles. Keep in mind that particle collisions work only with dynamic motion mode. Collision drag adds given factor to particles air drag, which slowdowns or accelerates particles motion after every collision. Bounciness allows to set up a factor which will multiply particles velocity, which is not exact thing as the drag, as it impacts only the motion at the moment of a bounce, that is without affecting future acceleration, while drag permanently slows down, which affects any future acceleration. Values below 1 will decelerate the motion after every bounce. Values above 1 will accelerate the motion after every bounce, while exactly 1 will do nothing to the motion. Collision radius determines particles' bounding box size, which will be used for collision. As a rule of thumb, you might want to use the same value divided by 2, which you used for size in appearance section. And finally, expire on contact allows to make particles expire when it collides with a block. Those are all the options provided by Snowstorm. However, that's not everything. All fields whose value appear in this input field on the top upon clicking, and don't have these increment arrows, allow you to provide math expressions. Math expressions are very flexible. You can do lots of stuff with them. You can do basic arithmetic operations, addition, subtraction, multiplication, and division. Beside that, there are a lot of different math functions and variables which you can use. You can look up those in help, Molang sheet. So here is a basic example of using math expressions to create a spiral. The way it works is by using 2 trigonometric functions, cosine and sine, with parametric motion mode. The way these two work is if you input into that function an angle on the circle, cosine will give you the x coordinate on the circle, and sine will give you the y coordinate on the circle. Both functions yield values between negative and positive 1. So if we'll set for x offset and z offset these two functions, and input particles age multiplied by 90, we'll see that particles will form a circle in 4 seconds. If we'd multiply both expressions by particle age, preferably divided by 4, we'll get a spiral. Besides using variables provided by this particle system, you can also create your own variables. Using variables section in the effect category. Under start variables, you can add some static values that you wish to use across multiple properties, but you don't want to copy paste them every time you want to change those. They are calculated every time emitter starts a cycle. And under tick variables, you can specify some variables that will be calculated every tick. Here you can use any of the emitter's variables or start variables. And finally, the last math element we have to review is curves section. Here you can basically create curves, which are essentially special tick variables which can be configured with curves. Name field allows you to specify the name of the variable which will be used in other math expressions. Mode dropdown allows to pick an interpolation. There are 2 modes available, linear and cat-mull-rom. Cat-mull-rom is the smooth one, while linear one is linear. Input is like interpolator in gradient color mode, a math expression that will determine the value which will be yielded by the curve. Range field is here a bit different. It basically turns the value yielded in input field and remaps it to 0 to 1 value range. So in case with particle age over particle lifetime formula, you have 2 options. You can either use the same formula and input 1 into range, or type in particle age into input and particle lifetime into range. Here in the graph view where you can add, remove and edit the positions of the points. Keep in mind that when using cat-mull-rom interpolation, the first and the last point are not part of the curve but rather are used to form the slope. Anyways, if we'll plug this curve variable into the size, we'll see it in action. I hope this tutorial helped you to learn and understand how Snowstorm works. Now you can make some anime particle effects. Before you go, here is a meme. Thanks for watching, and goodbye.